And well, maybe let's just start with Brad. Just give us a quick update on where your group is, and maybe a quick assessment of whether you think people will be able to wrap up in the next 2.5 hours or not.
We've gotten our set points programmed. We have not started our damper control logic yet. To be completed in the next 2.5 hours, I doubt it. I think it's going to probably take the rest of the period that we have allotted to get ours up and running.
Okay, so that's one for take as much time as we have available.
Yes.
All right, Mike, what's your group?
No, we don't have any of the guys in my group don't have any equipment set up to be able to actually program, so we're emulating.
Okay. So that'll be interesting. So there might be a chance you have, you might be able to get through that. Okay, Bob, you want to give assessment of our group? And
You're muted, Bob.
I was insulting Ted, so it's probably better.
I was going to comment about that, but
No, I actually said we got Ted, so we're going to win. It's going to be okay.
Right.
You know, I still think the logic functions. I mean, there's an advanced block, and I was looking over a couple of blocks last night. I think once we have occupied, clear and done, unoccupied, we have potential to finish if we have 2 hours. It's the fundamental construction is probably the hardest, I think. And how do we want to do this so we don't screw it up? And I think we got an opportunity to finish out. I mean, connecting it and tuning it, that's not going to happen. But yeah, I think we could have done some. If advanced blocks are, because I saw one that looked like it could fairly work well, I just have to play with it for a little bit. But when I look at the advanced blocks, you know, I think it's important to understand how to use all the other simpler blocks and try to get good with them to construct that sequence of operations first, or at least get somewhere near that. So we'll see. Talk is not going to do anything. Ted's got to get to work. Look at him. He looks like he's just taking it easy right now. He needs coffee and he needs a lot of yelling, and we'll be okay.
I need some of those pastries from the bistro.
Oh yeah.
So Rob McNabb. Oh, he stepped out, right?
Yeah. How are you looking there, Chris?
What is that?
We'll talk to his team individually.
Okay.
Yeah, so I got contemporary controls. I think I've got some stuff done. My level of success today will be just getting some basic function blocks in, saved, and just so I know how to do it. I'm much like Ted. I will only have very limited time on this, so a success for me is going to be much less than having the complete tables and all that done. So I'm doing in good shape.
Chris, how did your apparatus come out?
Pretty nice. It's turned out pretty well. For a trainer, it's turned out pretty well. I don't know if it's all that portable. I was hoping it would be a little more portable that I could take around and show people, but it's a work in progress, but it does all the things I was looking to do.
That's awesome, Chris. I love the reheat. That's great.
That's right.
That is awesome.
If I remember correctly, Stephen Chow, you were just observing or working in the simulator side. You didn't have any hardware.
Is he muted?
All right.
Yeah.
So that brings us to Andy's group. Andy, how's your teams looking?
We are rocking and rolling. You there? Yeah, we got, we're almost set. We've got like about 3 more stretch goals to take care of. We're actually programming it live. And so we've got airflow. We got to the PID part last night, and I've never tuned a real PID versus some simulation or spreadsheet. So we played with that last night. I have no idea what we're doing, but we've got it within, modulating within, I think, 1.5% of my airflow. And then we've got the heating side. We just fired that up, and then we're modulating to maintain 110. So Ted, we're all over it. It's really good too, because I'm coming at it from an HVAC side. Connie's coming at it from a programmer side. She's got some questions for you about the programming sequence from a line programming versus this, and some more discussion on that offline. But yeah, this is fantastic, and we should be pretty close.
That's great. Trying to put the rest of us to shame, huh?
Hey, I want to know what's going on with Chris Miller's garage there. What's going on with those pipes in the ceiling?
Yeah, I was thinking the same thing.
That's old school refrigeration. It's got our
Okay.
oven running through them. It's like a freezer.
Are you
All right.
making whiskey?
I resurrected the 70s. In my backyard, I have a solar thermal system. In my garage, I have a 200-gallon storage tank. So my workshop is heated by solar, and all the hot water is heated by solar. So I have, you'll like this. If you see right there, I took an old an A-frame coil out of a air conditioner, split it in half, and I run polypropylene glycol through it. And then on the ceiling, I have a radiant ceiling heat because I didn't have any floor heat, concrete. So this whole workshop is heated by solar hot water in the wintertime.
Phenomenal.
So that's besides all the electricity. So my house, I run, I have about 1
Periodic table.
watt-hour of extra electricity at the end of a year of electrical production. So my electricity is from the sun, and the workshop and the hot water comes from the sun.
Rock on.
Yeah,
Cool.
That's what
Wow,
I'm
you're net zero.
America.
trying.
he's net positive,
Yeah, 1 hour positive.
right?
Fantastic.
Do you have any
Nope,
battery
and-
storage?
And he didn't get the $50 million like that net zero building.
No, yeah, I did not. Nope. I'll be teaching a battery storage class in the fall. And so I'm working on maybe adding some battery storage to the house soon, but not yet. I'm getting there.
Okay. Excellent.
Do you have
Great.
any incentive for battery storage there where you are? We do in New York. They're moving on that pretty quickly.
So, yes, we got an electric car company in town that is building electric cars, but their other business model is they're building battery storage. And so I've got their apprentices right now, and that's where it precipitated. So I'm teaching a class on an intro to battery storage, battery assembly, not cell assembly, but building the battery packs and then getting students. In fact, I just had a student get hired in the assembly side of things over there. So they're going big on that. But as far as storage on electrical grid, it's not economically viable for us, at least in central Illinois. It's almost there in the Chicagoland region, as they're on a different grid structure than we are, but it'll be here. That's where we're going.
Well, that should be about it. Hey, Robert, as far as the
Well, Robert
check
McNabb,
on this.
Robert McNabb,
Yes,
how's your group doing?
I haven't, I just signed in. I was in another meeting. So I haven't been able to check in with them this morning.
Okay. I can say from what I'm doing, if I had been able to do this in Python, I'd have it done and dancing by now. And these doing block programming of logic and switches is really difficult for me. Somebody coming from a structured programming world is like, why? Spend a lot of time saying, why do I have to have a whole block for not or add? You know, I can do that with a single character, and I can have a variable that I can look at the state of it without bringing in another block. I can't believe that we're going to be living with this for the foreseeable future. It's just not possible to do the kind of complicated controls that we need to do to make things work with this kind of a block language. But I've written controls for my own house and in other things in Python and C, and I can choose. I don't have to do. I mean, it's nice to have the PID loop is nice to have as a block, but I could get that as a function. And the other thing about it is when you call a function, you send the parameters to it and you get the parameters back. You don't have lines that are crossing all over the place. And it just manages it so much more succinctly. I mean, I'm sure there are other people out there who have come from the IT world or programming world and have the same kind of problem, but I see it as being a real impediment to change and to getting control systems that are sophisticated. And then when we got to use AI stuff, which is, right around the corner, it's just going to be really challenging.
Robin, if I may address that, that's exactly the issues that I came from. Because I came out of college with a degree in computer science, all Java and C++ and C#. And then the first building automation system programming that I had to deal with was block-based IA programming through Visio. And it was absolutely a challenge. One of the things that I found that helped me was if you think of each of those blocks as a function call, because that's realistically exactly what it is. And you're partially correct. Our traditional script-based programming languages are exceptionally versatile. And at least at first, when you first start using block-based programming, it seems like it is really awkward and there's no way you could possibly get a lot of the advanced functionality that we can make our script-based programs dance in their jigs. But the truth is, the block-based programming, while it does take a little bit more time, can be nearly as versatile. There are definite times when that versatility comes from the background ability to write a block that will do the advanced function you need to, but it is there. And you're right that this programming style is a little bit more awkward for a lot of people. But the truth also is that the technicians we have in the field, you may have one or two, or maybe more if you're a big company like Siemens or Johnson, hardcore computer science type programmers in the background handling the big sequences and everything. But the truth is, those advanced sequences are still limited by the end service side. So if we need to be able to service those types of programs, those types of controllers, the service technician themselves has to be able to, at least at basic, understand that program. And the truth is, I'm not going to say the people in our field are incapable of doing that, because they are exceptionally intelligent people, but their skill sets don't lend towards that type of programming as well. With the block-based programming, it's much more, it feels much more like a hands-on wiring type activity, which many of our technicians relate to better than the classic syntax of a script-based programming language. So while I don't specifically disagree with anything you said, there are definite challenges associated with trying to transition to that. And keeping in mind that the building controls industry is 10 years or maybe a little bit more behind real IT will kind of help frame some of that. And I absolutely acknowledge that in 2010, IT was much further along in block-based programming, but there are other constraints that we do have to keep in mind.
Yeah, I would be, I mean, one simple thing that I'd like to see is just a connector for each of the folders. You know, that has it, just if we had a function that was just a connector that I could stick on the beginning for the inputs and the end of the sequence in the folder, it would make it much more organized than trying to bring your inputs and outputs sort of wherever, you know, there's a red dot going someplace and having to look that up. But anyway, yeah, I didn't mean to, I was thinking more, not about my own personal struggles, that's for me, but I was thinking about how we're going to manage to get to where we need to get in terms of energy reduction and energy usage in buildings if we're not working on this at a level that, you know, you got to have the technicians be able to work on it, but those of us who are doing more something else underneath need to be able to work at it at a much finer grained level than blocks, I would think. Even if we do like so many with object oriented, you can write a structured program, a little routine that gets stuck in with that. But then you'd be creating custom blocks, and I guess that would be problematic too. So anyway.
Not nearly as much so as you would think.
Robert, what in this context, if say the sensor goes bad or something else happens, are there advantages to the block-based programming that allow the technician to find the fault and address it in a way in which script-based programming wouldn't allow or would be less helpful?
That is a really great question, Peter, but it is less a function of script-based versus block-based and more of how company X implements inputs versus company Y, how they implement the inputs, and what functionality they allow you to, from a manipulation standpoint.
The other challenge I think in the block-based, just in particularly with GPT, is the 7-character naming limit. So if you had longer names, you could make them look like something. So when the technician went in, it said room temperature sensor, you know, and you could include the U1 as the channel so they could see it and it would be right there. But you know, again, it's just, maybe I'm just frustrated trying to make the change, and
no, we feel your pain.
I get grumpy when I get
Just frustrated. Every big box proprietary one, you can name it, describe it, pull it across the network. Yeah, if you knew ALC, you wouldn't be saying those things about block-based just because it's so versatile. This is just a $200 controller, you know, on an open sourceware programming platform that it gives everybody an opportunity. So, and we're not just thinking about technicians here. We have to think about the operators, right? It's not just the people installing or the controls technicians. It's every single person that has to interface with this. You know, trying to understand code, it's the only thing they understand or have been exposed to is ladder logic. And that's kind of what this logic-based programming is about.
On that note, we are going to have the training lead from ALC join us later today. And I think, you know, it would be really invaluable to have him be part of this discussion.
Lanny, you're from the IT side as well, I believe. Any comments?
Gotta work on his IT.
While Lanny's dealing with his audio, Steve points out that in some of his.
It's like God has spoken.
Steve Mayhew points out that in some of his one of his buildings, he actually has AI interacting with the building control system. And you're absolutely right, Steve. There are going to be instances where that is the case, but those are going to mostly be the exception. And I'm not saying that we as an industry aren't accelerating in our rate of change, just like IT did, but we're not 100% there yet. So while it's coming, absolutely, and it is possible for any system to integrate with any other system if you're willing to put in enough work, or if the manufacturers put in enough work on the background to create those interaction points. So, sorry, Lanny.
Oh, no, you're fine. So I have kind of a unique perspective in how I transitioned, because my IT background, I come from the hex programming, the COBOL programming. So I come from the old school of doing things. And then I moved into the HVAC side, and I learned about controls and programming, text-based, string code programming before I ever got into this this type of logic. And then I transitioned over into becoming more skilled and versatile in the more modern IT arena that we have nowadays. So I mean, I'm a person who kind of like Robin, personally, I'm very much visually oriented to text and language when it comes to coding, but I do see the value in this. And as Carlos Urquidi mentioned, visual learners, we have a lot of young students that are very visually oriented nowadays. They want to, they don't even care about what goes behind the coding. They more or less want to get to the graphics. They want to see the end result. But I think this gives them a very good foundation to understand the language. I think there is more versatility if we get away from the block-based programming. But in terms of how students work with this, I think this is a very, very good introduction, if you will, to allow them to look at because they can see a block and they can see what the purpose of that block is, and linking it to another block makes more sense in their brain versus trying to, even something as simple as the Siemens PPCL program. You're writing all these lines of code, and they have to see, okay, how does line 100 interface with line 600, which may interface with line 800. So they have to go through a lot of this code and back and forth. And visually, this is a lot easier because you're following that wire diagram. So in that sense, it makes it a lot easier, I think, for students to understand what's going on.
Yeah. Lanny, can I ask, behind you, is that plexiglass between your workstations?
It is. Those are our COVID shields, so that we've been back on campus since last year, and so we just had to prep all of our classes to make them COVID safe.
Okay. Good point. Thanks, Lanny, for sharing that.
Sure.
This has been a fantastic discussion.